With Einstein's mental models methodology, I already imagined the graphic demonstration of steady-state sinusoidal gravitational waves, and I characterized their frequency. I was also able to imagine a first experiment. The one with the pendulums in my previous video. Experiment having the formidable technical difficulties of detecting the weak gravito-electromagnetic interinductions of these pendulums. I am now proposing a new experiment with complexities and technical challenges far superior to that first one. The purpose of the experiment is to both detect and characterize gravitational waves induced by collisions being generated in subatomic particle accelerators, or in fusion reactors. Ideally, the aim of the experiment would be to synchronize LIGO with CERN's LHC, as for example, or with a performance test in any experimental nuclear fusion reactor. If necessary, the detectors installed in satellites and radio telescopes could also be synchronized, which would complement the typical detectors of those colliding facilities, which are settled to pick up the emissions generated by the collisions of these particles. It should be noted that punctual collisions between subatomic particles, likewise collisions between black holes, generate transient regime gravitational pulses, not steady-state gravitational waves. The results of both experiments, namely the pendulums and LIGO CERN, or any additional experiment for detecting all these interinductions, GUJE in chapters 2 to 5, will confirm the validity of my hypothesis, being that the GU continuum is a propagation media of all wave spectra in the universe. Up to this point, my GU continuum hypothesis has nothing to do with the Higgs field hypothesis. Maxwell published his equations to model the interaction between electricity and magnetism, without the need for quantum mechanics at all. They found at CERN the electroweak force, that is, interinduction between electromagnetism and the weak nuclear force, to which they attributed quantum character, by choosing to model it as interactions of particles in the Higgs field. If they had not chosen to model it through quantum mechanics, they would have needed methodology and constants equivalent to magnetic permeability or electrical permittivity, for a development corresponding to that of Maxwell's time. In the same manner, if quantum mechanics had existed when Maxwell developed his equations, he might have resorted to extravagant and capricious particles of the quantum circus instead of using permeability and permittivity. In any case, the existence of the electroweak force, to this day, supports both the model in the Higgs field and my hypothesis of interinduction, which is closer to Maxwell's model. According to my hypothesis of interinduction, alterations in any field of weak interactions, strong interactions, electrical, magnetic or gravitational induce simultaneous and reciprocal interactions in all others. The goal of the experiment I proposed in my previous video is to measure and characterize the lower end of interinduction, which corresponds to gravito-electromagnetism. With the data provided by that experiment, sufficient knowledge would be accumulated on the interinductions between gravity, electricity, magnetism, and weak force. Completing the upper end of the interinduction hypothesis would only require quantifying the existence of interinduction between gravity and strong nuclear interaction. Knowing that the strong interaction is more than 100 times more intense than the weak interaction, 130 times more than electromagnetism, and 1,000 times more than gravity, I suspect that the technical challenge will be, roughly, to track on each collision the weak interaction and electromagnetism effects, in order to be able to subtract them, if the LIGO filters will not behave sufficiently accurate.